So part 6 of Advanced Engineering Mathematics Practice Final Exam, number 16. Solve u sub t equals 9u sub xx on the interval 0 is less than x is less than pi with boundary conditions u of 0 t equals 0, u of pi t equals 0, and initial condition u of x comma 0 equals x, pi minus x using separation of variables. So heat equation problem. So u sub t equals 9u sub xx, 0 is less than x is less than pi, u of 0 comma t is 0, and u of pi comma t is 0. U of x0 is x pi minus x. So using separation here, u x comma t, that equals capital X of x, capital T of t, then x capital T prime equals 9 capital X double prime t. So capital T prime over 9 capital T equals capital X double prime over capital X, and that equals negative lambda. So the boundary value problem is x capital X double prime plus lambda capital X equals 0. Capital X of 0 equals capital X of pi equals 0. So lambda sub n equals n squared. X sub n of x equals sine of nx. And the time factor is capital T of n of t equals e to the negative 9 n squared lowercase t. So u of xt equals the sum from n equals 1 to infinity, b sub n sine nx e to the negative 9 n squared lowercase t. So the coefficients are b sub n equals 2 over pi times this integral from 0 to pi x, pi minus x sine of nx dx. So we could say b sub n equals 4 times this quantity, 1 minus this negative 1 to the n, close parentheses, divided by pi n cubed. So from that, we know now that only odd n can occur. Okay. So u of x comma t, that equals the sum here, n equals 1 to infinity of 4 times the quantity 1 minus negative 1 to the n over pi n cubed sine of nx e to the negative 9n squared lowercase t. And u of x comma lowercase t equals the sum here from k equals 0 to infinity 8 over pi quantity 2k plus 1 cubed sine of this quantity, this 2k plus 1 times x times e to the negative 9 times this quantity 2k plus 1 squared times lowercase t. Okay, so that is number 16. Moving along now here to number 17. So 16 was heat equation, 17 is a wave equation. So for 17, solve u sub tt equals 16, u sub xx subject to u of 0 t equals 0, and u sub x l comma t equals 0. With initial conditions, u of x comma 0 equals sine 3 pi x over 2l, and u sub t of x comma 0 equals 0. Find the exact solution. So this is a wave equation with mixed boundary conditions. So u sub tt equals 16, u xx sub xx, u of 0 comma t equals 0, u sub x of l comma t equals 0. So the separated spatial problem is x double prime plus lambda x equals 0, x of 0 equals 0, x prime of l equals 0. The eigenfunctions are x sub n of x equals sine of this quantity 2n plus 1 times pi x over 2l, where n equals 0, 1, 2, and on, those whole numbers, positive. And corresponding wave frequencies are omega sub n equals 4 times this quantity 2n plus 1 pi in the numerator divided by 2l. Initial displacement is u of x comma 0 equals sine of 3 pi x over 2l, and this corresponds to n equals 1. Also, u sub t of x comma 0 equals 0, and we could conclude from there that therefore u of x comma t equals the following: sine of 3 pi x over 2l cosine of 6 pi t over l. And now number 18 here, we want to solve u sub xx plus u sub yy on the rectangle from 0 to x. 0 is less than x is less than a, where 0 is less than y is less than b, with u of 0, y equals 0, and u of a, y equals 0, u of x 0 equals 0, u of x comma b equals f of x. And we want to derive the full Fourier series solution. Okay, so this is a Laplace equation on rectangle. So solve u sub xx plus u sub yy equals 0. 0 is less than x is less than a. 0 is less than y is less than b. With u of 0, y equals u of ay equals u of x 0. That equals 0. And u of x comma b equals f of x. So we're going to use separation here. U equals x, capital X of x, capital Y of y. Then capital X double prime over capital X equals negative capital Y double prime over capital Y, and that equals negative lambda. So the x portion, the x problem is capital X double prime plus lambda capital X equals 0. And this x of 0 equals x of a equals 0. So lambda sub n equals this quantity n pi over a squared. So x sub n, capital X sub n of x equals sine of n pi x over a. The y problem is y sub n double prime minus n pi over a squared, y sub n equals 0. Since u of x comma 0 equals 0, we choose y sub n of capital Y sub n of lowercase y, and that's going to equal the hyperbolic sine of n pi y over a. Therefore, u of xy equals this sum from n equals 1 to infinity. A sub n hyperbolic sine of n pi y over a sine n pi x over a. So applying u of x comma b equals f of x, and f of x equals this sum, n equals 1 to infinity, a sub n hyperbolic sine of n pi b over a, sine of n pi x over a. So a sub n hyperbolic sine of n pi b over a, that equals 2 over a times this integral from 0 to a, f of x sine of n pi x over a dx. So a sub n is going to equal 2 over a hyperbolic sine of n pi b over a times the integral from 0 to a, f of x sine of n pi x over a dx. So from there, performing the computation, just simplifying, well, this is going to become the u x y equals n equals 1 to infinity for this sum, bracket 2 over a hyperbolic sine of n pi b over a times the integral from 0 to a, f of xi sine of n pi xi over a d xi, sine hyperbolic sine of this is n pi y over a sine of n pi x over a. Sorry about that being so condensed. And I know a lot of people pronounce psi much differently. Many professors pronounce it much differently. But that is part 6. Thank you very much and have a great day.